Hello, everyone. Welcome to Celebrating Aviation with Mike Machat. We have a wonderful episode for you today. We're going to be looking at aircraft with nuclear propulsion. Whether they flew or were just in concept, we're going to get into that, and I think you're going to enjoy this program. But overall, when you look at nuclear propulsion today, nuclear power, it's an accepted routine part of society. We have electric power stations. We have the bulk of Navy ships, aircraft carriers, and submarines that are all powered by nuclear propulsion, and this has become pretty much routine. However, in the mid-1950s, this was a pretty radical approach. And at the height of the Cold War, you had two superpowers, each with nuclear weapons and nuclear capability. And it was a very interesting and very intense time at the thought of the possibility of nuclear war. To address that, the United States had what was called the nuclear triad. And that was three separate systems of delivering nuclear weapons to a target, if that ever had to happen. Number one was the manned airplane. Number two were underground missiles in silos. And number three were missiles on submarines that could be deployed worldwide. Each component was very important, and here's why. The airplanes were the only aspect of that where the machines could be called back if there was negotiation or if something changed in the scenario of delivering the weapon to a target. The submarines were vital. They were manned, obviously, but they could be deployed worldwide. But once their missiles were launched, they were on their way. And of course, the same with the underground ICBM. So the airplanes played a pivotal and critical role in that aspect of nuclear deterrence. The American aerospace industry called to come up with designs of aircraft that could deliver nuclear weapons to a target. And the idea of nuclear power gave these airplanes much greater range and endurance. They didn't have to be refueled. They could stay in the air for days, if not weeks, if need be. And again, this is before routine aerial refueling for aircraft of this type at this time. So we're going to be looking at these machines in detail. We have a couple of surprises for you as well. Let's get into it. We're going to show you an ad from a 1951 copy of Air Trails magazine, a very popular aviation publication at that time, and it's got some very interesting facts and figures on nuclear propulsion. The ad that you see here says, locked in 1 pound of the fissionable material U-235 is energy equal to 6 million gallons of airplane gasoline. It is no wonder that engineers are planning to propel future airplanes with atomic power. The two largest problems were weight and deadly radiation. The weight of the nuclear reactor itself, plus the lead shielding required to protect the flight crew from radiation, would require a very large aircraft. The benefit, however, was that nuclear-powered strategic bombers would be able to stay airborne for weeks at a time. And this is where Convair proposed a perfect solution, their B-36. A number of aircraft manufacturers proposed their ideas as well. And here we have three examples from the Convair division of General Dynamics: the NB-36H, the proposed NX2, and the Model 23A jet seaplane. The first Convair airplane we're going to look at in detail is the NB-36H. The B-36 was conceived at the end of World War II as a long-range, long-endurance, heavy bomber that could potentially go from the United States and reach targets in Europe and return. It was never developed in time for World War II, but it was then adapted for that same role at the beginning of the Cold War, being able to deliver a nuclear weapon to a target halfway around the world and return. It was the only airplane that was large enough and heavy enough to carry a nuclear reactor in a test mode, and that's where this airplane earned its keep as the NB-36H. The original airplane was powered by 6 piston engines and then later augmented with 4 jets, which originated the term 6 turning and 4 burning. In order to evaluate a nuclear-powered jet aircraft, the project utilized a Convair B-36 bomber as a testbed aircraft, and only one B-36H was modified during the early stages of this project. The B-36 bomb bay could carry 40,000 pounds and could easily carry a 1 megawatt air-cooled nuclear reactor weighing 35,000 pounds. The reactor, named the Aircraft Shield Test Reactor, or ASTR, was operational in flight, but it did not power the airplane. Large air intake scoops were added to the sides of the aircraft's rear fuselage to help cool the reactor in the air. This modified B-36 was called the Nuclear Test Aircraft, or NTA, and was redesignated first as the XB-36H, and then the NB-36H with the N prefix signifying a permanent, non-changeable modification. The sole purpose of this airplane was to investigate the effect of radiation on aircraft systems. To shield the flight crew, the fuselage nose section was modified to include a 12-ton lead and rubber shield. All the windows were eliminated except a new windshield, which was made of 6-inch thick acrylic glass. The NTA completed 47 test flights and accumulated 215 hours of flight time, 89 of which included the reactor operating in flight. These flights took place between September 17, 1955 and March 1957 over New Mexico and Texas. This was the only known airborne reactor experiment in the United States, with an operational nuclear reactor on board an aircraft in flight. The NB-36H was scrapped at Fort Worth, Texas in 1958 when the nuclear aircraft program was abandoned. Based on the results of the NTA, the entire nuclear aircraft program was abandoned in 1961. Had the program evolved to a nuclear-powered airplane, it would have been designated as the X-6, the sixth in the fabled series of X-planes, and the B-36 was the only airframe that would have allowed that to happen at that period in time. This is the Convair NX2. It doesn't get any better than this for a futuristic design out of the early years of the Cold War. You have to remember that America's aerospace industry was looking forward, and you had very futuristic looking machines with canards, giant tip fins, serrated sawtooth leading edge, and a nuclear power plant on top of all that. This predates things like digital flight control systems, stability augmentation systems, and a lot of the advanced aircraft components that are flown in airplanes today. But it makes it even more unbelievable and more impressive when you look at a machine like this or a design like this that would have been science fiction just 10 years earlier and yet would have flown had they gotten the program to that point in time. From a press release by Convair in 1959 comes the following, quote, "The NX-2, America's first nuclear-powered aircraft to be built for the Air Force by Convair Fort Worth, will have a subsonic canard configuration and will be approximately the same size as the current Boeing B-52 Stratofortress. Present Air Force schedule calls for extensive flight testing using conventional engines with hydrocarbon fuels before the first flight with nuclear power, which is expected to take place in late 1965. According to this press release, the NX-2 will fly with either General Electric direct cycle GEX 211 engines or Pratt & Whitney indirect cycle engines. Both engine types had dual capabilities, working as either conventionally powered turbojets or with nuclear power. The GE direct cycle power plant was considered as a, quote, dirty engine, unquote, after the 3 jet turbines had been supplied with hot air from the reactor. They would emit radioactive contamination into the atmosphere through their exhaust streams. Therefore, to help reduce this contamination and augment aircraft performance as well, 2 underwing J-57 turbojets were used to provide additional thrust on takeoff, climb to altitude, and approach for landing. On the other hand, the 4 Pratt & Whitney main engines did not pollute, so there was no need for the extra J-57s. I know what you're thinking. I've got a model of a Martin Seamaster in front of me, but it looks a little different. Well, it does. This is the Convair Model 23A jet seaplane, a radical but sleek-looking machine developed to not only deliver nuclear weapons and become a mine layer as well, but it would be serviced by submarines or ships anywhere around the world. But a T-tail nuclear propulsion system, radically swept wing, sleek nose. When RFPs, or request for proposals, were issued for nuclear-powered aircraft, the U.S. Navy made a very strong case for nuclear-powered seaplanes. The world's first atomic-powered submarine, the USS Nautilus, had already demonstrated the advantages of nuclear propulsion by cruising thousands of miles without refueling in 1956, including a history-making submerged voyage to the North Pole. By the mid-1950s, Convair was working on nuclear aircraft propulsion on 3 different fronts. It was already flying the land-based experimental NB-36H, was conducting design work on the NX2, and, along with the Model 23A, B, and C seaplanes, created a triumvirate of nuclear-powered aircraft. These were based on the company's vast experience building flying boats, from the legendary PBY Catalina of World War II fame to giant turboprop-powered trade-wind troop transports. Convair conducted a number of design studies that resembled different size versions of the Martin Seamaster, strategic bomber, and mine layer, as well as their own Sea Dart Delta Wing fighter, but with different wing configurations. It should be mentioned that the Sea Dart was the world's first and only supersonic seaplane. Although the Model 23A was designed as a long-range attack aircraft, it could also conduct aerial mine laying and photo reconnaissance. Its swept wing was to have a span of 76 feet. We talked about having some surprises and having something very special to show you, and here it is. This is a military application of the Douglas DC-10 airliner, specifically the DC-10-30 Intercontinental version. And this was an airplane that was adapted as a missile launcher. Now, why would they need to do that? Well, we talked about the nuclear triad earlier in the video, and you had the ground-based missiles, the aircraft, and the submarine-launched missiles. This was a device that would allow intercontinental ballistic missiles to be launched in the air. They would be ejected out of the airplane and then would follow a trajectory to the target. We've shown you the outside of the airplane. Now let's take a look at what's inside in this beautiful cutaway model. As we come after the cockpit, there's crew living quarters, which includes a table and a little dining area. There's an airliner-type lavatory, and then there's rest stations, crew bunks for obviously multiple crews that were on board, taking turns manning their stations. Then you have the communications area, I'm sure very highly classified intercept and communications gear, and then the operators who would man those stations during operational missions. As we come further aft, you notice the missile bay. It contains 2 MX-style intercontinental ballistic missiles. There's one aperture on the lower aft fuselage through which they are ejected. So one missile would be ejected, then the second missile would be moved into position and follow suit. Once the missiles were clear of the airplane, the engines would ignite and they would be on a pre-planned trajectory to their target. The rest of the airplane is exactly the same as a DC-10 Series 30, convertible freighter actually, and this is powered by 3 General Electric CF6-50C2 turbofan engines. The remaining part of the airframe is identical to the DC-10. So we've talked about missiles, systems, and warheads. Let's take a look inside the box and see what a multiple reentry vehicle looks like. So here is the nose cone reentry system for the missile, and as I turn it around here, you can see the multiple warheads. There were 2 basic configurations. This one holds 19 smaller warheads on each side of the housing, and then a different system had larger warheads, 3 on each side, 6 total. Believe it or not, each one of these warheads was individually programmed on a trajectory to an individual target. So you can see it was a very innovative system, and all I can say publicly today is that there are versions of this in operational use for the nuclear deterrent of the United States. It was a system envisioned back in those days and used today. So there you have it, a look at the peak of America's aerospace greatness with nuclear-powered airplanes and some surprises in terms of delivering the weapon systems to their targets. Hope you've enjoyed this episode. We'd love to have you on board as a subscriber if you haven't already, and please do hit the like button on the way out. That helps us in a big way with YouTube. As always, until next time, take care.